Welcome to our very last video, part 2 of step 34. So in this video, we're going to talk about how to assemble and read a two-way frequency table. So a two-way frequency table, we've already been working with these when we talked about like mutually exclusive and not mutually exclusive events. We did an example where there was there were paintings and stuff. So you know what these are. You may have never heard them called two-way frequency tables yet, but let's do our first one and then this will make more sense. So Michael is asking a random sample of 160 upperclassmen if they plan to participate in drama club. He finds that so many seniors and juniors plan to attend while so many do not plan to attend, okay? So for the first thing we want to do if we're ever trying to organize a frequency table is identify what we call variables, okay? This is the same thing, like equivalent to like characteristics, okay? How are we distinguishing these people differently from each other? Like how are we collecting the data? So one way we are doing that is based on their participation. Okay, he's really worried about are they attending or are they not attending? Okay, the second thing he's doing is based on their class. Okay, are they juniors or seniors? Okay, so that's how he's differentiating between the group of people that he's interviewing. Okay, so in our table, along the left-hand side and across the top, we're going to write these variables or characteristics. So I'm going to write across the top, attending, and then those that are not attending. Okay, and then I'm going to put over here our seniors and juniors. Okay, once you have that all labeled, now we're just going to put it into our table based on his numbers. So he said that 44 seniors plan to attend, so we're going to put that in this upper left-hand corner where seniors and attending would cross. 25 juniors are attending, so we're going to put that just below the 44. 32 seniors are not coming. And 59 juniors are not coming. Okay, so we put in all the data that he provided us. So you're probably wondering what is going on with the extra boxes. Well, in any table, we like to consider our totals. Okay, so in each column, you're going to add them together. 44 plus 25 would be 69. 32 plus 59 is 91. 44 plus 32 is 76. 25 plus 59 is 84. Okay, and our very last box, the very bottom row and the very right column should equal the same thing. So 69 plus 91 is equal to 160. 76 plus 84 is also equal to 160. And a way to kind of check ourselves to make sure that we actually did it correctly is we can scroll back up and say, and it says that he took a random sample of 160 upperclassmen. Okay, the basically total of our totals, right, the very right-hand corner added up to 160 people. So we know that all of our numbers are in the right spot. Okay, so now we're going to talk about how to kind of read a frequency table. Okay, so we have things that are called marginal frequencies and joint frequencies. So remember, if something's for gauging frequency, that's just how often something occurs. Okay, the marginal frequencies, if you think about the margins of your paper, Okay, these marginal frequencies come from the outside. So these all come from the totals. The joint frequencies come from the middle of the table. Okay, so if it's coming from the middle four numbers that we had filled in, that's joint frequency, and marginal would be coming from the total. So if we want to go ahead and label this chart, okay, so the marginal frequencies appear at the margin of our paper around the outside. So these numbers would be the marginal frequencies, while the joint frequencies are on the inside. So any joint frequency comes from the middle. Okay, so we're just going to start by, it already has the table filled out for us. It's just asking some questions and then asking us to clarify, is it marginal frequency or joint frequency? So we want how many red jet flights arrived on time. So if we go to red jet and then go over to where it says on time, that gives us 7 flights. Okay, and that number came from the middle of our table. It did not come from a total, so this is a joint frequency. Okay, and then part B, we want how many flights arrived late. So we just are worried about all of the late flights. So there were 9 that were Air World, 11 that were Red Jet, which means there's 20 total flights that were late. And since that number came from the outside row, this is going to be a marginal frequency. It came from one of those total columns. Okay, we're going to go ahead and move on because hopefully we kind of get the idea. So we have something else called a relative frequency. Okay, this is basically just converting our charts into percentages or fractions. So a relative frequency is the ratio of the number of observations in a category to the total number of observations. So I already gave you a table. Okay, it's already filled in. This is actually the same table that we did in example 1. Okay, and we are going to convert this to relative frequencies. So the first thing we want to do is label the chart the same way. Senior, junior, totals, participating, not participating, and totals. Okay, so what we're basically looking to do is to convert these to percentages. So the first thing we need to figure out is how are we going to write these instead of just numbers as a fraction in order to then convert them to percentages. So what we're going to do in order to start to find a relative frequency is we're just going to take each number in this chart and put it over the very total. Okay, our very total here, if you remember from example 1, was 160 kids that we talked to. Okay, so we're going to take each number, keep it where it's at, but we're just going to put it over 160. Okay, then the next thing we want to do once we have it as the fraction is we're going to write these as percents to the nearest tenth. So our labels are going to stay the same, senior, junior, totals, participating, not participating. Okay, so since we already have them as fractions, we can just put this in our calculator in order to find the actual percentages. So the first one, senior participating, is 44 over 160. So in your calculator, you can type 44 divided by 160, and you're going to get a decimal. Okay, in order to convert this decimal to the percentage, we're going to multiply by 100, or you can think in your head to move the decimal 2 places over, and we get 27.5. We wanted to round to the nearest tenth, so that's 1 decimal place. So 27.5%. Okay, so if I move to the right, I'm going to do 32 divided by 160. Oh, not 162. 160 times 100, and I get 20% perfectly. Okay, if I keep moving to the right, it makes sense that if I put 76 over 160 times 100, I get 47.5%, which makes sense because if I added the 2 that I already did, 27.5 plus 20 should get to 47.5. Okay, so just for the sake of time, I don't want to make this video super long, so I'm just going to go ahead and put the percentages in here for us. 15.6, 43.1, 36.9, 56.9. Okay, and part of the reason you know that you can find your percentages correctly is to make sure that all the totals actually add up the same way that our fractions and all of our other numbers added up. And then the very last thing is this bottom box, the very right hand. Remember, that number is the total of all of the totals. So it's all of the people that were in our sample. So 160 divided by 160 is 1, and when we multiply that up by 100, we get 100%. Okay, so you can also check that you did this right, that very bottom right corner should always be 100%. Okay, so we're going to tie this back into conditional probability. Okay, remember, conditional probability is the probability of something given something else already happened. So remember, this is the probability. So if I said A given B, I would want the probability that both things are happening over the probability of the given. Okay, this is coming from part 1 that we hopefully just did or did earlier. Okay. Oh, no. Okay, so we already have our chart already figured out. Okay, it's the chart that we just did. We are trying to figure out, a student plans to attend the festival given that he or she is a junior. So we want the probability that we know they're going to attend given that this person is a junior. Okay, so on the top, we want the probability that both things are happening. So we want to look at the number that is attending and junior over just the probability of the given. Okay, so the given would be that this person is a junior. Okay, so if we want to find attending and junior, we just want to find the juniors that are attending, which is 15.6 over the probability that somebody's just a junior, and that is 52.5%. I don't know why that keeps popping up. Okay, and I'm going to put this in my calculator, try to simplify it for us. 15.6 over 52.5. Then I'm going to multiply by 100, and it gets us to about 29.7%. Okay, so just kind of wrapping it all back into conditional probability like we did in part 1. And that is your very last video. I'm going to cap it, make sure I stay under 15, but congratulations, you are finished.